Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem that is a Pacific Atlantic water flow. This is a like pretty popular question and you should actually understand how this question works. So this works by most more or less on graph theory, or you can say using some BFS or DFS algorithm. So that's the basic idea. We'll understand what exactly the question wants to say and how we should what should be our approach to find the solution to this kind of question. Okay, so that will be the whole thing about this video. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular lit code videos like this. Let's understand what it is. The question says there's an M cross in rectangular island. So that's an island given to us. Okay, so let's just scroll it a bit. So basically there's an M cross and rectangular island. Okay, let's see this example and understand as it is. Fine. So firstly, there's an M cross and rectangular island. Now in that the borders that borders both Pacific and Atlantic Ocean. So there's like Pacific Ocean as a border and there's like Atlantic Ocean as a border. Fine. So there we have it, right? Now further, what the question says, the question says the Pacific Ocean passes the island on the left and the top. So Pacific Ocean is on its left and on its top. Fine. So that there's the Pacific Ocean and Atlantic is at the right and the bottom. So there's the right, we have Atlantic, and on the bottom we have so the further question says the island is partitioned into a grid, okay, of square cells. So that's the grid we are given. So that's like you can say a matrix is given to us. So that's the square cells. Okay, fine. And you were given an m cross n integer matrix. Fine, and integer matrix being given to us being called heights. So that's the heights being given to us. Fine. So that's it. And where height rc, that's any of the height is like the height above the sea level. So if we just look carefully at this thing, so this thing is like given at 5, so that means this 5 is like 5 say any unit above the sea level. So that's the height above the sea level. Fine. Say you are at 1, so that 1 means 1 unit above the sea level. Fine. So as we say, like just think of a topographical map of any place or any continent or any island specifically. So it's an island. There on one side there's a Pacific Ocean, on the other side there's an Atlantic Ocean. Right now, what is the height at each point or each of the like the squares in it? So it's being denoted as like this. So just simply a topographical map is given to us. Okay, that's the understanding. Now, further it says the island receive a lot of rain, so there happens a lot of rain, and the rainwater can flow to its neighboring cells directly north, south, east, and west. So, as you can understand, if this is a topographical map and there's a lot of rain happening on the island, what will happen? The island, the water will flow in all directions. The water will say there's the rain happened on this small area. Okay, just for understanding, let's rain happen on this small area. So, water will flow on this top, what is flow on his left, right, on his right, and on his bottom. So what will flow all sides, right? So that's the understanding. But how, when, why it will flow? See, if this is our still under consideration, water flow top? No. Can water flow on its left? No. Why is it so? The idea, like the question, normal thinking is, if water can water go from a height of 1 to a height of 3? Like think normally, like there's an object, like okay, there's an object that's of height 3, fine, and there's another object that's of height 1, fine. Can water grow from here till here naturally? No, right? So that's what it is saying. If the neighboring cell height is less than or equal to the current cell, then only it will move. Like if from 3 to 1, it can move, but it cannot move previous like 1 to 3. It can also move. Say there's like 3 and there's another contain like another neighboring cell is there that's also has a height 3. So it can move, fine, but it cannot move up, right? Water cannot move from sea till to our mountains like directly naturally through our rivers. From rivers, if we see through rivers goes from mountains till the ocean. So it's the natural process they're describing it to us, fine. So water can flow from any adjacent to the ocean and to an ocean and like into the ocean, right? That's the uh, process it happens, and that's the natural thing you need to understand. Now, what the question asks us to do, the question further says like return a 2D list. So it will be returning a 2D list. That's the list over here of like result what result of I will be a row column index. It will be like each of the items in the list will be an say array or a list itself, where there are two elements, row and column, so that denotes the particular cell, okay, from where water can flow to both Pacific and Atlantic Ocean. So that's idea. The what it means is like we fine, we say we find at any cell what we will do, we'll check for say we took this cell, okay, we will see that from this cell water can flow to Atlantic Ocean. It can go up, it can go left, it cannot go right, like it cannot go right, fine. So water moved there, fine, because it's like less than or equal to, so it can go up for it. But further, can it go left or go up? Like we need to, like anyway, the water that fell on this particular box or this particular cell, can it reach to Pacific Ocean? No, right? like like you need to see, you need to go above, right? That's not possible. So if we cannot do that, so this is not a cell that we are looking for. What are the cells that we are looking for? A cells from where both the Atlantic and the Pacific Oceans can be reached. Okay, so say what it means. Say there's an ocean, like exactly there's an cell like this five. Fine. In this five, if the water falls on it, the water can go up, the water can go down. Fine. Even the water can go left or the water can go right, because all of its left, right, north, south, like north, south, east, west, all of us are lower than it. Fine. And further, from 4 it can go to 2, and from 2 it can go to Pacific Ocean. From 3 it can go to 1, and from 1 it can go to Atlantic Ocean. And once we can, by any way, okay, so there can be multiple way as well. From 3, from the top 3 you can go to 2, and it can go to Pacific Ocean, or simply going down, okay. Or from each of the cell, like from this particular 3, this particular cell, it can go to left and it can go to top, fine, and then Pacific Ocean. So there can be multiple ways to reach the Pacific Ocean and Atlantic Ocean, but we need to check if there's like a single way is present or not, okay. There must be a single way, okay, through which we can reach uh, both our oceans, okay. So if we can reach both the oceans, okay, if we can reach, we just need to return, like add that coordinate of that cell, like from where we can reach both the oceans to our final result. So the result only asking for those cells or the coordinates of those cells from which we can actually reach both the oceans. Okay. So what should be our idea? Like how we should approach it? So first of all, when you come across this kind of question, you should be more or less clear with this idea that when you are getting a question where you need to find a path, okay, there should be a single path, or you are finding a single solution. Okay, when you're trying to do something like this, then you should be aware that your like your solution is going to be having some graph on it. Fine, that's the first thing. Now, if you are given a graph, how you should do go ahead with that? You can start from the first, like you can first go ahead on each of the rows, okay, and then go ahead on each of the columns to just see that if a current row, like say we are at any of the like particular uh, cell, okay, we need to see, can we reach the end from any of the like this particular column, can we reach the Atlantic Ocean? And we'll kick another like the thing, see that thing will go in such a way that you are keeping two different grades as a Boolean grades to check for whether you can actually reach the one is to check for the Pacific Ocean, fine. Uh, Pacific Ocean, and other is to check for the Atlantic Ocean. Fine. So that those are two grids we need to keep as a boolean. So we need to check for each of the cell, can we reach the Atlantic Ocean or the Pacific Ocean? So first we'll start from this particular box, fine, this particular box, and we'll see, can we reach the Pacific Ocean or not? Okay, if we can reach the Pacific Ocean, we'll mark that true, fine. Then we'll see, we'll keep checking for each of the cells, fine, and we'll keep a note that can we reach the Pacific Ocean or not with that idea. And then at the same time, we'll keep a check for the Atlantic Ocean also. Like for each of the box, can we go for the Atlantic Ocean or not? Fine. Can we reach the Atlantic Ocean or not? So there's an common idea that happens is like, see, if we first keep checking for the columns, okay, say we are checking for the columns first, or we are checking for the rows first, okay. So if I first checking for the columns first, like we're going only through the columns, then what will be our check? Our check will be, if a column is here, we are going from column 0 to column n, like through all the columns. So our at Pacific Ocean values we know will be towards the top, right? On the from 0 0 it will start, fine. And our Atlantic Ocean values will more or less will be on this is on the bottom and right side, fine. So how we should go then? So if we are at Atlantic Ocean, is there any need to check for this particular column, like the one like 0 0 column, right? We may need, like, it's not compulsory that there isn't any need, but on like general understanding, our like the chances that this particular column, this particular 0 0 column will end up giving water to the Atlantic Ocean as well. Like we know that this particular column will anyways give water to the Pacific Ocean, because we are not bothered to see if the if its surrounding is ending in Pacific Ocean or not. But we are sure that this will end up in Pacific Ocean. But we need to check whether this column can end up in Atlantic Ocean or not, right? So if that kind of situation is there, so is it a nice idea if we start our Atlantic Ocean count from here, because we are trying to reach the Atlantic Ocean that is on the right. Okay, so if we're trying to reach the Atlantic Ocean, then it's not a good idea to start from 0 0. How about we start from this particular rows, because over here we know that it will end up in Atlantic Ocean. Like this particular column, it will anyways end up in Atlantic Ocean, and this particular column and this particular, I mean not column, I mean this particular cell and the this particular cell, this two will always be a part of our answer, fine. Because on one hand this will end in Pacific, on the other hand this will end in Atlantic, fine. This is the idea. So there's no need to start our check from for Atlantic Ocean from 0 0. We can start our check for Atlantic Ocean from this particular cell, right? This particular cell will keep checking farther towards the north, towards the right. Okay, so that's what we'll keep checking, because till the point we cannot go above. Like if we can go above, like if it's like we find that after 5 there's a 6 is there, so that means 6 can give water below, like towards the Atlantic Ocean. So once we find that, we will like move above. If we cannot find that, we will move towards the right, because we won't be going further, fine. So that's the idea, because we will keep checking whether our previous value, say our previous value is this, our previous value is less than or equal to our current value. If it's like that, we like the same condition. Okay, so if our previous height is on both sides, if our 4 is less than or equal to 7, it will move further, fine. Like we are trying to check the reverse way, fine. We are, what we are doing, we are not following how the water will flow, we are following the reverse of how the water will flow. And then we'll try to understand that this particular water flows in like top to bottom, but we are trying to go ahead with bottom to up, okay, to find out which particular like boxes will actually end up in like all the boxes. So in this case, what will happen actually, if I just draw this area as an Atlantic Ocean to you. So what will happen? This 5 is there, fine. This 4 and 4 is there, okay, and there this 5 is there, fine. 5 3 1 is there, and there you find that 6 7 and then 1 4 5 is there, fine. So what will happen in case of Atlantic Ocean? Our end result will end up something like this: 5 1 1 2 4. So all these cells, okay, all these cells will give us a result that all the cells water can actually reach Atlantic Ocean. So our Atlantic Ocean array or Atlantic Ocean Boolean array we are taking. So this will store that this cells will be true and this other cells we have, okay, other cells we have will be false. And on the other hand, what our Pacific Ocean array will store, it will store just the reverse. It will store the exact positions from where we can reach the Pacific Ocean, right? And further, we'll do an m cross n loop where we'll check if both the positions are going to be true, like both in the Atlantic Ocean is true and in the Pacific Ocean is true. That means we are able to reach our destination. Like we got those cells which is like having both in the Atlantic and Pacific, right? And we'll add them to our result. So before wasting any further time, quickly write the code. First, we'll write another function, a DFS function over here. Fine, a DFS function. This function will be helpful for us in terms like this will be helpful for everything we need. This will be doing all the DFS search because from each of the cell we'll try to find out north, left, right, and bottom to find out whether our water can actually move. If our water cannot move, then this is not true. Like our particular action we are trying to find is not true. Fine. So that's the idea. And that's how we'll be moving ahead. Fine. So here it is. Let's quickly write our code. Fine. So here you can see like this is a 13 millisecond solution. Not the fastest because here you can do multiple modifications. But let's understand what exactly and how we try to solve this question. Fine. So the first thing is this DFS. This is a function that we are using for traversing and checking whether our current positions and all the neighboring positions that can be visited. Fine. Now what the DFS has, it has to ij being the coordinates we are currently checking. Further, it has a visited array. Okay, so visited array can be our Pacific array for a Pacific or the Atlantic, depending on what we are sending each time. Fine, we'll understand those upper parts a bit later. But we have this visited array. So this array just keeping a check whether we have visited this current node or not. Visited IJ is true or not. Fine, that's the task of this visited. Further, we have a previous height. Previous height is being our starting height. So the previous height we are checking if we have already uh, checked that our current height is being reached or not. Like our previous height is just storing the previous length so that we can compare whether we should go forward or not. Okay, in that way. And then we have this height setter, the height setter being given to us as input. Fine. So what is the first check? For the first check is if we are checking I is less than zero, like we're just taking the terminal condition. If I is less than zero, that means it's going on the left, or I is greater than equal to number of rows. Number of rows in the sense say there are 5 and I is going somewhere out of this. Okay, so those are the outside conditions, boundary conditions. Our j is less than 0 or j is greater than equal to the number of columns, that is j is going for the out of the boundary conditions. Or we find that this particular cell is already visited and we know from this cell we actually found a way out. Okay, it's already visited, that exactly means we actually know there's at least a single way to reach our particular water body we are trying to search at this moment, either Pacific or Atlantic. Not both at the same time, but either one we are trying to search at each step. Further, we're just checking if our previous height is greater than our current height. Okay, our current height is smaller than our previous height. That means this is a condition we cannot move forward, right? Our current height should be like a previous height should be like less than or equal to our current self, right? That's a what? That's a what we are given a condition, and that's how the nature works as we understand it. So if the reverse is case is there, we cannot move there. So that's the all the conditions where we cannot move forward, and thus we simply return. Let's say no, we cannot go forward. And further, what we did, we just make our visitor being true. Just make sure we just visited the cell, and we simply checked that if we simply checked for the four other cells, for the cells being top, bottom, left, and right. That's a top, plus one being bottom, minus one being top, and j plus one being right, and j minus one being left. So that's the four sides we have checked of the each cell, and then we try to find for each of the cells those which are already being like we can visit by that. Okay, so that's the idea. That's the whole idea. Say we are at this one at the Atlantic point. We are going towards the top. We find that we can go, and then we going towards the top. We find we can go. Fine. Also, we try to check for the left. We try to check for the right. Right, we cannot go. Fine. Well, at this 7, we find we can go for his left, and we can go for his right. Similarly, we find that no, we cannot go out of like to be honest, like we can go in the sense, but we cannot go. It's like more like we are just checking for the all the sides, okay, and then we're trying to find out whether we can find a solution, like we can reach the water bodies, okay, just a DFS solution on the reverse way. Fine. Now let's understand what exactly we did in our solution, main solution. We took the two visited array or Boolean arrays. One is specific for the Pacific Ocean side, and this for the Atlantic Ocean side. Now, what are we doing? We are going for each of the columns. Fine. For each of the columns, we are starting. We are doing calling a DFS function. Now, what we are starting for the Pacific Ocean, we are starting from like column start from 0 till column counts, so all the column counts. So we are giving the Pacific Ocean a column count, starting column count, that is 0i. 0i, see 0 being like a 0 and our current column, fine, and 0 being the topmost row we have, fine, topmost row we have, and column is changing. So that's like that's the best case we know that we can reach Pacific Ocean, fine. That's the best case because those are all need to be true, fine. Now, what else? Other cases, we are just passing like 0i, and the other one is we are passing for the Atlantic Ocean is rho minus 1 and I. So rho is the total row count, fine. So that's the total row count, and rho minus 1 is being the last row, okay, because it starts from 0. So last row will be our rho minus 1 and followed by I. So our current column and rho minus 1. So we know that our last row is 1. That will definitely be in Atlantic Ocean, fine. So that's what we're doing for the Atlantic Ocean. And what is our starting height? Because here you remember we have previous height. So previous height is our current, like the last row in our current column. The last row cell is our like the previous height for Pacific Ocean, like Atlantic Ocean, and the first in our current column, our first row height is the Pacific Ocean height. Okay, so that's the check. That's the whole check. Now again, we are going from after we are done with for each of the columns checking. Now we are checking for each of the rows. Okay, so that's the next loop, checking for each of the rows. And the similar case, we first give it in as a like left side row for the Pacific Ocean and right side row for the Atlantic Ocean as a common case that will reach both the like or Atlantic Ocean for all. Okay, and once we done with our checking for all the cells that can be reached based on that, next thing we are going to do is like create an answer array list. This will be the final return, and we go through the whole like the whole 2D matrix. So for each of the rows and for each of the columns, for each of the row in each of the column, we just check if Pacific of ij and Atlantic of ij, I mean, if both the cells node, like for each of the coordinates, if both of these as are true, like we can reach Pacific and we can reach Atlantic are true, then means we simply add that to our answer, fine, and ultimately return our answer. So that's the simple idea. That's a simple idea. It's not that simple, but you need to understand the coding as well. So that's how we actually solve this kind of question. The main tricks goes in this particular idea is like in this DFS function. Okay, so that's all it is, guys. So I hope I can make you understand how you can solve a question like this. And thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.